Now, this is where all the action happens in the neuronal system. It's called the synapse, and this is the point at which we see the transmission of energy, electrochemical energy, from one dendritic spine to another. And these can occur in any of the cells that we've reviewed so far, no matter what the shape or type. We always see a synapse, which is the point of contact between the cell with another cell. So let's begin by looking at a neuron that we will define here as a presynaptic neuron in figure A. So this is the neuron where we assume the action potential is residing for the transmission of electrochemical activity through the axon to a receiving postsynaptic neuron. So pre refers to the action potential residing within this neuron. Post refers to the reception of that energy according to different kinds of neurophysical properties. So let's review a little bit. We have here the cell body with the nucleus. We have the dendritic spines coming off the cell body. Here you see it's a multipolar cell, so possibly a type of motor neuron. We also have the axon, which includes the myelin sheath and the nodes of Ranvier. And here's a glial cell thrown in for good measure. The glial cell here is only functioning to give structure to the cell. It's not engaged in any kind of electrochemical transmission, and that's why it's sitting up here, attached but not with any particular active function. There's no action attached to the glial cell. Then we've got some arrows here, and these arrows indicate the direction of travel of the electrochemical activity. And these arrows are always going in one direction, which implies that there is only ever feed forward or one-way traffic inside the axon. Now, this is an assumption that we've had for literally hundreds of years, but in fact, this has been called into question whether the direction of travel of the electrochemical activity is always one way, or can in some sense also be considered to be feedback, but we'll leave that question for the time being. It's sufficient to assume that the electrochemical activity that runs through the axon is running in a feed-forward direction only. Now, when we get to the end of the axon, we see again some more dendritic spines, and here is where the interesting activity that allows communication between the presynaptic neuron and the postsynaptic neuron to occur. So the postsynaptic neuron is identical in every way. It's got a cell body, it's got a nucleus, it's got dendritic spines, and within the edge of the cell body, we've got labeled here something called a synaptic terminal. Now, this is a little bit like a docking station where you might bring a boat into port and dock the boat at the terminal so that you can allow the contents of the boat to exit into the terminal itself. So the word terminal refers to the movement of the contents of energy within the dendritic spine of the presynaptic neuron into the cell wall of the postsynaptic neuron. And we'll now take a close-up look at what's going on inside the synaptic terminal, and that's this figure here. So if we take a look at B, we'll see that the presynaptic neuron is feeding through the axon to this final point. And within the axon, we see a number of different features. So this is actually zoomed in several hundred times to show you what's happening at the postsynaptic and presynaptic junction. Now, in here you see some small circles. These are containers of neurotransmitters. Neurotransmitters are the chemicals that enable signals to be transferred from one brain cell to another. So there are several of these, and they're all floating around within the dendrite. We also see here some other substance, which are mitochondria. These are proteins, and they have less to do with the transmission of neuronal signals than the neurotransmitters. The formal name for these round circles is vesicles, and the number of vesicles that we have within the dendrite will determine how much neurotransmitter is passed from one cell to another. The goal of the neurotransmitters is to modify or change the activity of the postsynaptic neuron. So sometimes neurotransmitters can be used to inhibit the activity of the postsynaptic neuron, and sometimes they can be used to excite the activity of the postsynaptic neuron. So these excitatory and inhibitory functions are performed by the neurotransmission of chemicals within the brain.